Okay. Now, welcome to the next section, and for now, the final section of statistics before we go into ADA. When I say ADA, it is exploratory data analysis. So here, when we delve into it, just want to recap that the last installment of this whole class was about probability density function. This is what we understood. This is what we understood, that this is your probability space, and this is also the sample or event space for your probability calculations when you calculate probability of a certain event, right? So this one below is the whole thing. This whole thing here is the one which goes in the denominator. And if you want to calculate a particular event, the probability of happening of a particular event, that goes here. Okay, I mean, what is the number of times it is possible. So it gives you the probability of data point falling within some given range of a given value. So finding probability is always a ratio between something and something, right? And that something and something is below it is all possible ways, above it is number of ways your favorable or interested event can happen, and number of ways all the events can happen. This is always true. Okay, when all the events are embodied inside this probability space. This probability space was developed by expressing the entire distribution in terms of its distribution from the mean and all these standard deviations, every data point. So I hope you're getting that this is not going to be easy. This is not going to be straightforward. Again and again, you'll have to find different real interpretations of the figures that are in front of you. You will eventually, maybe you will come up with a very different view yourself, which again will cyclically, connect to the same truth. But I would encourage you to go ahead and, you know, get that imagination working. And this is not a poetic imagination, this is mathematical imagination. So there is a end and there is a convergence here, and it doesn't simply keep diverging. Okay, I hope you understand what I'm saying. So, yeah, that's what it is. Then after that, we came into probability mass function. The difference from here to here is we bucket everything, okay, as we did here in one of the sections. You see here, we did that from 0 to 1 lakh data points. We bucketed. So we bucketed everything, and then all now we need them. We will just put them, take the average of it, average of each bucket. Each bucket now here contains 10,000 points, 10,000 points, 10,000, like that. You have 10 buckets. That eventually makes 1 lakh points for us, because we started with 1 lakh. And if you plot the entire 1 lakh here, it will take 1 lakh points, 1 lakh iterations to find the probabilities, because this is probability. It will take 1 lakh iterations to find the probabilities of each. Correct? Because there are 1 lakh points. So instead of that, why can't we just make it just 10 points by taking 10k each? Or you may choose to take 5k in each bucket, which makes it 20 buckets or 20 points, which are mean values. Like that, it's up to you. I mean, if there are 1 crore data points, you may want to do it in a different way. So finally, you can do that, and you will get this idea. Why? Because eventually we are interested in only the shape of the distribution. Next. Next concept, while we are working with shapes, there are different shapes. See, one thing you have to understand, Now is the main gist. Hope we are all ready for this. Start with distribution. This distribution, again, where is distribution coming from? This distribution pre the source of this is your data. This data comes from event. Okay, then we take the mean, standard deviation, and PDF. Once we take this, one of the possible shape is a nice bell. One of the possible shape is a nice bell curve. If between 0 to first sigma and 0 to minus first sigma, if 34%, if in the given distribution 34% of the data lies between the mean and the first sigma, minus 1 sigma, and 34 lies between the mean and the first sigma, and if this continues further and you get a final bell curve, if you get this, okay, then it is a normal distribution. So one of the possibilities. Another possibility. The shapes can differ. Another possibility is you can have something like this. Now this one is the probability space. Here, wherever your mean value is, this is not going to follow this principle. It's not like the mean and the first sigma will have 33%. No, here the distribution, the PDF's conditions are different here. This is also an event. This is also an event. That's what you have to remember. Not every event or data and the distribution leads to normal distribution. But we can find the probability density function of every distribution, and one of the PDF may look like this, another PDF may look like this. Depends on the event. Is it clear now? Is it connecting, Manjunath?
Yes, sir. I'm getting. I'm getting. So the possibilities way of the graph, the distribution may be different here. That's what you are trying to say us.
Vikas, would you like to
And
elaborate on that?
Yes,
and the
yes, sir. So
sigma.
at the end of the day, it comes down to the event which produces the data, and it can give us either a smooth normal curve or it can be any other shape for that matter.
I, Manjunath, what I'm trying to say is,
Yes, sir.
I just want to make sure that you understand the hidden hidden truth here. ನೋಡಿ,
Okay.
ನಾನು ಕನ್ನಡ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ನೋಡಿ.
Okay.
ಇಲ್ಲಿ ಇವೆಂಟ್ ಅಂದ್ರೆ ಏನು? ವಿಕಾಶ್, ಐ ಆಮ್ ಗೋಣ ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಇನ್ ಕನ್ನಡ, ಓಕೆ?
Yeah, sure, sir. No worries.
ಇವೆಂಟ್ ಅಂದ್ರೆ ಏನು? ಇವೆಂಟ್ ಅಂದ್ರೆ ಸಪೋಸ್ ನೀವು ಒಂದು ಡೇಟಾ ಕಲೆಕ್ಷನ್
But
ಇವೆಂಟ್ ಮಾಡಿದ್ದೀರ. ನೀವು ಒಂದು 1000 ಜನರಿಗೆ ರೋಡಲ್ಲಿ ಹೋಗಿ, ಓಕೆ, ನಿಮ್ಮ ನಿಮ್ಮ ಫಸ್ಟ್ ಇವೆಂಟ್ ಒನ್, ಇದನ್ನು ಇವೆಂಟ್ ಒನ್ ಅಂತ ಮಾಡ್ಕೊಳ್ಳೋಣ. ದಿಸ್ ಇಸ್ ಗುಡ್ ಎಕ್ಸಾಂಪಲ್. event 1. You are asking on the road to 1,000 people, huh? 1,000 people survey on the road. Personally, Manjunath is going and surveying. Uh, how much was your 10th standard score? So you have a Excel sheet now, 1,000 points ಇದೆಯಪ್ಪ ಈಗ huh? After correct no?
Yes, yes, yes.
ಈಗ second event. While you are asking that, you ask another question. Present income. This Excel sheet also has 1,000 points because you asked all the 1,000 people, correct?
Okay.
So, but some people will agree to tell you the 10th standard score,
Yes.
but some people will tell you the 10th standard score, but income they will not disclose. It's like, ನಿಮ್ಗೆ ಯಾಕ್
Yeah,
ಬೇಕು? Why you want that?
yeah, both things can happen. So some people will not share the salary also.
Right, right, correct. So you are not sure that all 1,000 entries are there. For
Yeah.
event 1, maybe eventually you will get into event 1, you will get 871 entries. Event 2, you will get 922 entries. That too, some
Mm.
people must have, it's very imbalanced data. Some people said
Mm.
yes to 10th but no to this. Some people said yes
Yeah,
to this
yeah.
but no to that. So there's a whole of imbalance. Now to get and clean this data,
So we require Panda.
correct. To clean this data, you need pandas.
So
After
got it.
cleaning the data, you will now plot the probability density functions.
Okay, okay. Panda is the entry gate, first gate.
Correct. Okay. Now this event 1, whatever you see here, this event,
Mm.
this event 1 distribution will be like this. And this event's distribution will be like this. This is income inequality. This is a Lorentz distribution. This is Lorentz income inequality curve. If you take a PDF also, you'll find the same. This is your probability space. The shape is different here.
So how can we predict the zero, sir? So zero will be uh, where we can plot here zero. So it is easy to here for another possibilities. So where we can plot zero.
Here only, this is here in this case, your mean value will be somewhere here only in the center.
Okay. So that will gives the graph will gives the mu value and
No, I'm sorry. Here, I think a mean value will be somewhere over here. Most of them will be below the mean.
mm,
Okay, in the distribution, most of them, because some people will have high values here because income is like that. No, few people, if you ask everybody out of 1,000 people, or if you take in the whole world, you see here, this is what your percentiles talk about. So before I get into percentile aspect, I want you to see this. Uh, many people, out of 1,000 people, there will be 500 people earning, let's say, 5 LPA. Then there will be around 200 people earning around 10 LPA. How are they on average if you take their own means? Then there will be another 200 earning around 15, probably another 50 earning around 20, maybe another 25. running around 25, and the remaining, you can say, 15 and 5 and 5. Okay, 30, 35. So have I not made 1000 here? 400, 450, 25, 25, 500, 500, 500, 1000. 1000 members data is in front of you. If you see this graph, few people are earning high. So the probability density of them, the probability of you finding them is very less. But there are very few people. So if you take 5 into 35, it's going to be these people, no, these people hardly are 25, but they make the large chunk of money. So this is not your normal distribution or your Bell's or your Gaussian distribution. This distribution is different. So when you eventually find the mean value of it, you will, wherever you start from the mean and then start putting the distribution, you will find that just around the positive aspect of the mean there will be very less. But as you go deeper, minus 1 sigma, minus 2 sigma, you will find more like this. If you start with mean here, here you will find less, here you will find more. So eventually your graph looks like this. That's why your mean will be here. That's why I said your mean will be somewhere over here. Your mean. So now that talking about that, this particular graph also gives you an idea of another statistical, another stats called percentiles, not percentage. This is percentiles. Now, what a percentile is you should think in a practical aspect. In a data set, what's the point at which X% of the values are less than that value? That's the percentile. Okay, if you say 78th percentile, okay, 78th percentile, which means 78% of the whatever that score you have, let's say here, let's say this is 75th percentile. So this $85,811 income, which is here, is 75th percentile, means 75% of the people are earning less than that. Hmm? Making sense? This is, I mean, this is not like a discovery, as I told you. See, this is not like discovering gravity. Gravity is there. That's it. Even if aliens come, they have to discover gravity. But if the aliens come, there is no aliens means if there is an alien civilization somewhere, it is not necessary. They will discover gravity while living, but there is no guarantee that they will express a stats called percentile. You're understanding? They may have a different kinds of statistics. They may see numbers and everything very differently, but they cannot see gravity differently. Okay, I hope you're understanding. This is another way of looking at the stats. When you have a lot of numbers, you are trying to check that given the distribution, what is the value which makes me come to the 99th percentile. Suppose if you want to, where this percentile thing comes, Vikash will know, right, Vikash? Because you would have worked on that, this thing for your exams, competitive exams and all, correct?
Yes, right, sir. Yeah, right. So in checking the rank of students, like how many people are below
Let me give an example. See, after this is over, I'll share the recording. You have to see the recording again, pause and make notes and send me. I will hold it accountable. You have to come to the uh, office and show me those notes of yours. Okay, both of you. Hmm. Percentile. See how the whole percentile thing differs now. Percentile.
There actually
So,
just one question here.
mhm,
So earlier while we were discussing that income data set, like you showed some examples, right?
mhm.
Out of 1,000 people, 500. So over there, if we plot the PDF, it
Okay.
would be looking like exponentially decreasing curve, right? If we plot the PDF, we saw a percentile curve, but if we look at the PDF, it will be the other way, right?
This one, that thousand,
The 1,000 example, yeah, yeah, right.
500 people with 5 LPA and all that, correct? That one.
Correct, right, right.
So if you take the mean value of this
Hmm,
5 LPA, 10 LPA, no, whatever the plot is, it's okay, fine. If you're finding it, then if you take the mean value and then no, then take the sigma
hmm,
and find out how many data points,
hmm.
you can actually do that. You can do a hand calculation of it. Yes. Why don't you actually do that? I'll give you this.
Yeah,
In the recording you will get it. Okay,
yeah,
that figure, right? How will you calculate if there is 500 people's, this is
hmm,
500 people's combined data now.
yeah,
So which means that you actually have to make I'll give you a data set for this
yeah.
and I'll
Or else
plot and show.
we can scale it down, saying we just take 10 people. Out of that, five are in 5 LP, something like that. Maybe we can
You can you
scale
can you
down.
can scale and do it. I would say you guys do that exercise. Then
Okay,
we will
okay.
discuss. You come with the figures, then we'll
Yeah.
discuss and you will, of course, if it is going to look like this,
Hmm.
uh, it means that if there is a mean somewhere over here, it
Hmm.
means that more people are above the mean. No, right?
No, sir. The mu would be towards the end only. That was right.
Huh.
But the distribution would be decreasing, like exponentially decreasing, probably because
No, where will you find more people?
more
Data
people
point,
would be in
probability of,
the mid value, sir.
no, above. If you take the mean of this 5 LPA, 10
Hmm.
LPA, then what, 15 I did, right? Then I did
Yeah.
20.
25 and 30.
But you should also take this as 5 into 500, the mean value,
Correct. Correct.
and then divide by 1000. So if you do that, you will get some value.
It will be somewhere around 10, sir. 10 or 12. That would be the,
Mean value, is it?
yeah,
No, no,
approx.
no, no. Wait, wait, wait. It can't be like that. These are very less. These are more. This is 200, 200, 50, some 25, 15, 5, 5, 30, 35, 40. You have to do this multiplication.
It's 25, 450, 175,
25 into 5,
175, 170.
140, 175. This is
Only two.
4,000,
7,
5,000, 7,500, 8,500, 9,000, roughly about 9,000 divided by 1,000. So you have 9 LPA
yeah.
as a mean value. And 500, see this whole thing, half of them are here only then,
Hmm.
less than 50% are here.
Yeah.
Then slowly you will find 200, 20%. Slowly. This won't be like a distribution like this, right? Where you
It
have,
won't be a perfect normal, sir, but somewhere similar to that is what I'm thinking.
see, this is
Because
exactly like this. Half of them are here only now.
correct.
Lot of people are here, right? So slowly it increases, where you'll find another 20% here, another 20% here. Then slowly you will find, right? So at one point of time where the maximum value is, you draw that reference from there. So that's the reason why I said this. If you take this mean value here, you'll find more people here. There's more number of people, although less, but the tail will be dragging. It will be long tail. There's a lot of people will be there, no?
Right. But sir, I'm not very sure about the right hand side because ideally, as the number of data points decreases, the curve should, I mean, it should go down, right, towards zero. But here we have put it as increasing exponentially. So maybe if we plot and see, then probably we might get a different
What
understanding.
is this value? What is this value? This is zero income.
Correct.
These are number of people who are earning that.
Hmm.
Hmm.
But for PDF, we have to compute mu and sigma, right? Basis mu and sigma, we'll be plotting the curve because if we go with the salary, this is right. I mean, I agree that this would be the curve.
Hmm.
But if we do PDF for this, maybe somewhere more or less it will be like a normal distribution, like not exactly a normal curve.
If you go like that, yeah, it
Right,
will
right,
be a no, if you take the mean value here,
right.
you will have a lot of points here, but then you will have less here.
Mostly people would be concentrated around the mean, and then again the top ones will start decreasing. Yeah,
Something like that. It would be a fine, I understand. See, this is a skewed distribution.
correct.
Okay. So fine. The another way of looking at the skewness is this. So
Correct,
this
sir.
you
Yeah.
can say Lorentz inequality curve. That's why it is called a Lorentz inequality curve.
Hmm.
But fine, I understand what you're trying to say. Is I understand. Uh,
Yeah.
right. Oh, good. Yeah. What about Manjunath? Were you able to follow what we were discussing?
ಸರ್ ಅರ್ಥ ಆಗ್ತಾ ಇದೆ ಬಟ್ ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಆಗ್ತಾ ಇದೆ ಸೊ ಲೆಟ್ ಮಿ ಗೋ ಥ್ರೂ ಒನ್ಸ್ ಅಗೇನ್ ನನಗೆ ಅರ್ಥ ಆಗ್ತಾ ಇದೆ
Okay.
So, ನಾನು ಅಷ್ಟೊಂದು ಕ್ವಿಕ್ ಎನಫ್ ಇಲ್ಲ ಸೊ ಮ್ಯಾಥ್ಸ್ ಅಲ್ಲಿ ಸೊ ಲೆಟ್ ಮಿ ಗೋ ಥ್ರೂ ಒನ್ಸ್ ಐ ರಿಟರ್ನ್ ದ ಕೋಡ್
Hmm.
ವಿಲ್ ಹೆಲ್ಪ್ ಮೀ
What happens then? See, if you keep distancing yourself from the thinking aspect, you'll become a machine learning engineer rather than a machine learning scientist. There's a difference. Engineering, you'll implement it. Once told, you'll implement it. You'll code it. You're drifting towards getting that coding done. But what you actually are supposed to do is retrain your mind to think in terms of data.
Yeah,
So this is going to be
so
difficult.
transparency, the transformation is now I'm putting hard. So transformation of the engineering mind into scientist mind.
Uh,
So there
that is,
need
that
to work.
that needs to be worked on. It is going to not be easy, but consistent effort will eventually get you there. So fine. But then, as you see, scientist means perspective. There is no step to become a scientist. Only the scientific mind is inquiry, mind of imagination, where you check, prove, right? So like how Vikash was trying to do here. So we were there. I was giving that, and then he gave that when you go into a distribution aspect, then it's a skewed distribution that comes up. That's fine. We'll come there eventually. See, the skews are a part of this, so we'll eventually get there. See, the skews. We'll learn that also. So fine. The income inequality. I was just trying to give you both the sense of percentiles as well as a different kind of distribution. So, anyways, so that's where I was drawing. I hope because you're able to understand that I wanted to show this as well as give you a sense of uh, a different kind of distribution as well. Anyways,
Right,
now
right.
coming back to percentile, Manjunath, percentile is suppose there is an examination which has around 1,000 people. Very difficult examination. Okay, there are only 10 seats in this, and 1,000 people are writing this exam. Uh, so, because you want to select only 10, you will not give a cutoff marks like if you score about 90%, we will give you the seat. Everybody is out of 1,000 people to 200 people can work hard and come up and say, I have scored 90%, I worked hard, you told me so. Now 200 people will come and ask for 10 seats. What will you do then? Only 10 seats for it. So instead of asking for the percentage cutoff, you will ask percentile cutoff, saying, okay, 1,000 people, I have set up a very difficult question paper which has to be solved in 3 hours. If you want to really complete the whole question paper, it may need 15 hours, but I'm going to give you 3 hours and I want to check the scores. I want to check the scores of each. Then I will say the cutoff is 90th percentile. It means only the top 10% of the people will be called for the interview and then 10 people selected. Okay. This is a competitive exam setup. So when I say 90th percentile, what it means? It means 90% of the values are less than that value. So 90th percentile, whatever, let's say, suppose you said 99th percentile is 90th percentile, suppose was out of a 100 marks question, out of a 100 marks question, 90th percentile was the one who scored 18 marks, 18 on 100. So everybody who scored below 18 are out. Everybody who scored above 18 can attend the interview now. 18 on 100 becomes the 90th percentile. Is Artha ಆಗ್ತಿದೆ Manjunath? Manjunath, are you there?
Yes, sir. Yes.
Did you understand this?
So, ಒಂದ್ಸಲ ಕನ್ನಡದಲ್ಲಿ ಹೇಳಕ್ಕಾಗತ್ತಾ?
ಅದಕ್ಕೆ ನಾನು ರೆಕಾರ್ಡ್ ಮಾಡಿ ಕಳಿಸ್ತೀನಿ ಕನ್ನಡದಲ್ಲಿ. ಓಕೆ,
Okay.
right. The quartiles and the percentiles in this one is fine. I'll also, um, this is a different way of looking at it. These whole things are, you know, a deeper insight into the data itself, where given given the data, suppose given the 1,000 data points that you have, the question is why should you calculate all the stats for all the 1,000 data points? Why can't we just divide them into sections and do the stats separately on it? The same thing what we did here in histogram when we were bucketing it, right? So here there's the bucketing done where you first divide this data 50% here, 50% here around the median value. I mean, it's not, once you have a median value, there's no, there's no guarantee that you'll have 50% on the other side or 50% on the other side. It's not, there's no guarantee for that. Okay. But then your first division happens around the median. Okay. Then after that, once you have divided whatever is remaining here, then you redivide it again in quarters. So you eventually have the divider is the quartile, okay, between the first two. Then the divider between this, the second is the Q3, the third quartile, and the second quartile is your median, okay, the median value. Basically, very simply put, it's not difficult, it's not really a big thing which is happening. Whatever you're seeing in front of you is what is happening. Just they want to see how there is a deviation from quartile to quartile. What if for the first 25% of the data, nice uniformity. The graph is very nice here in distribution. Second also graph is very nice. Suddenly in the third distribution you may feel there's a slight skew around the mean. The fourth again is graph is very nice. So at least you are able to check the median from median to the third quartile. Here the data skewing is more, baki rest everything is following the normal distribution. At least this we identified. No, otherwise what happens if you take the PDF of all of it at once, you sort of will get a shape like this, which almost looks like a PDF, but you don't know where that skew is getting. But at least now you know that this particular quartile data has a slight right skew or a left skew. I'm just giving you, say I'm playing with the distributions. I hope the connection is made. Okay, to be able to identify, isolate, because what did we do now? We took the event and divided that event itself. Maybe 1,000 minutes of data was collected. First 250 minutes, what happened? Like you can see, in the movies also you can check how the interest of the people was in a particular movie. So everything was first quarter, second quarter, and after the interval, it just went down. Story got haphazard. Then that's the reason why the movie is a flop. So analysis has to be done in different ways. It depends. That's why data scientist is a very clever chap. The thing was always observe the events. How will you collect the data? Once the data is collected, what reference system is there to measure it? Once the reference system comes in, then all the measurements comes in. Okay, so this is the stuff of IQ, scientific mindset. This is the stuff. This is the one which gets paid. Okay, so I hope you're understanding it. So eventually you'll get the hang of it. Fine. That was quartiles. Now going deeper into quartiles, going a little deeper. What did I do? Do you want the snapshot picture of it or the video is enough, right? Correct? Video is enough. You can take a snap there. Okay. Going deeper, you have even more complicated measures where you're still seeing the same distributions here. You're still seeing the same distributions here, but for different data, there are different measures. You see here, as I told you, there is this median, then there is Q1 and Q3, where your data is. This one, it's what you're seeing is a different kind of plot. Okay, this one is a box plot. What you're seeing is a box plot. Why box? See, this is the box. I'm not saying it happens. I'm not saying this happens all the time. I'm saying in this example, We are saying percentiles in a normal distribution looks like this, expressed by interquartile range between Q1 and Q3. Above Q1, above Q3, there are some elements whose values can be sort of, instead of just expressing in sigmas, you can say whatever the Q3 value here was plus 1.5 into the interquartile range, whatever this value was, the difference between the value Q1 and Q3, whatever this was, you will find the Q3 above every data above this, this range, this value, and inside this you will find all the data, all 100 points, but most of them are here. What is this meaning of this? Because most of them are here, no? Here also when you did 34 and 34, 68% are here only. The rest of them, what we did, uh, how much was it? 16, 12%, I think 6%, and whatever points were there. Out of, see, this is like if you take 1,000 people's data, 680 people's data were here only, no? That is what a percentage is. 34% means out of 100, 34. So out of 1,000, 340. So if you take the distribution of 1,000 people, 340 are here, 340 are here. So 680 people are here only. Baki rest of the 320 people, which eventually boils down to 160 people, 160 people distribution are here, and that too those sigma distributions are given here, and here they are saying that the range is different. Nobody does this now. This is more into data science aspect of it. Okay, more into data science aspect, where you may want to see a problem like this, or you may not, when you're trying to explain a lot of anomalies and this one you will get into this. But just for the sake of completion, I'm trying to tell you that as you move forward in data science, you will eventually find different ways of observing an event or a data set. Event ಅಂದ್ರೆ observing a distribution. For a normal distribution, this looks like this, so you are looking at it like this. And this, as I told you, is a box plot, which we will eventually do. We are going to learn about box plots when we are going to learn about, when we are going to do hands-on statistics with the Matplotlib. There you will see this happening. There is a second connect that you will have. So fine, you can rewatch this again and connect it. And I'm telling you, there is no royal road and easy road. Okay, it's not like you have to find the institute or a program or a mentor who can make everything easy. Yeah, we can discuss, we can go into the depth, we can go example by example by example, where if you completely are immersed, it will become easy. Eventually, you will learn the language of scientific description, it will become easy. But you have to also go through the path. Okay, I'm sorry. So that's what I was aiming at. So there are different ways of looking at it, depending on how flat or how peaked the distribution is. You will find that there are certain ranges. So we'll leave it at that. Moving forward, now comes one of the important. Now comes the practical aspect of statistics. All the stats that we've been doing so far, I kept saying, let's suppose 1,000 points. Let's suppose 1,000 points, right? I kept saying all the time. We need to add some perspective on that also. Manjunath, you there?
Yes, Vijay.
Yeah. So every time, because for your understanding,
Yes.
uh, we every time I was suppose like that's what I did, right? Wherever every time I wanted to explain something, I'll say, suppose there are 1 lakh points. Suppose there are 1,000 points. What is that suppose? That suppose whatever I'm trying to do is a sample. Suppose there is a sample of 1,000 people. whose distribution just happened to be for the marks distribution, 10th standard marks distribution happened to be like this. Suppose there are 1,000 people. When I plot 1,000 people's data, I'm getting the fact that 680 people's score are between plus 1 sigma and minus 1 sigma. Suppose I'm doing this. But this one is only a representation of the 1,000, which is a sample from the population, because you did not ask all the 6 crore people in Bangalore or 150 crore people in India. Correct. We didn't do that. So we can't do that as well. That's the whole idea of stats. Since we cannot collect all the population data, we collect the sample and then we do the descriptive statistics of it. Descriptive means all these mean, median, mode. Then you try to bring in the inferential aspect, which is your probability density function, and you try to find the skews of it, and you find the estimation, hypothesis testing, and all this. Means what? Means you took the sample, you found the 1,000, okay? Then you on this sample, for let's suppose again the marks distribution only, you found out for the sample the distribution looks like this. Means what? For 1,000 people, 680 people have scored between the first sigma and minus 1 sigma. They've scored like this in the sample. Now I want to predict this, not this. This is done. My money or value or success is in being able to predict things about the population, not the sample. The effort to collect the sample and do all this drama of describing and inferring was so that you can predict things about the population. So when the sample gave you a PDF which is following the normal distribution, there is one more question which begs to be asked, which is what is the guarantee? What is the guarantee that just because the sample is following the normal distribution, somebody from randomly picked up from the population, or a new sample that comes out from the population will also follow the normal? What is the guarantee? That's the question. So this part of what is the guarantee is called the estimation. Finding out what is the guarantee is the estimation. And a cusp between the description and inference, to help you draw the inferences, you describe the data using mean and the standard deviations and your PDFs. You describe it. Okay? So you get this. So, Manjunath, slight clarity, something like you know, the story getting added, like why we were doing all these things, some perspective on where we are going, what's the whole game about. Are you getting that idea? Manjunath, you there or we lost you? Okay, Vikash, you there?
Yes, sir. Yeah. And
Okay. This is clear. Probably you already knew it, but I guess
ಸರ್ ಅರ್ಥ ಆಯ್ತು ಅರ್ಥ ಆಯ್ತು ಇಂಟರ್ನ್ಯಾಷನಲ್ ಸಾರಿ ಇನ್ಫರೆನ್ಷಿಯಲ್ ಸ್ಟಾಟಿಸ್ಟಿಕ್ಸ್ ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ವಾಟ್ ಇಸ್ ದಟ್ ವರ್ಡ್ ಸ್ಟ್ಯಾಂಡ್ಸ್ ಫಾರ್
inference ಅಂದ್ರೆ
ಇನ್ಫರೆನ್ಷಿಯಲ್
describe and infer. describe ಈಗ ಹ್ಮ್. if you
ಡಿಸ್ಕ್ರಿಪ್ಟಿವ್
ask
ಅರ್ಥ ಆಯ್ತು ಸರ್. ಸೊ ಥ್ರೂಔಟ್ ದ ಕ್ಲಾಸ್ ಯು ಎಕ್ಸ್ಪ್ಲೈನ್ ಡಿಸ್ಕ್ರಿಪ್ಟಿವ್ ಸ್ಟಾಟಿಸ್ಟಿಕ್ಸ್ ಅಂತ ಏನಂತ ಅರ್ಥ ಆಯ್ತು. ದ ಸ್ಯಾಂಪ್ಲಿಂಗ್ ಆಫ್ ದ ಡೇಟಾ ಆಫ್ ಈಚ್ ಪರ್ಸನ್ ಅಂಡ್ ಕಲೆಕ್ಟಿಂಗ್ ದ ಡೇಟಾ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಡಿಸ್ಕ್ರಿಪ್ಟಿವ್. ಬಟ್ ವಾಟ್ ಈಸ್ ಇನ್ಫರೆನ್ಷಿಯಲ್ ಅನ್ನೋದು ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ.
ಈಗ suppose you ask your daughter, suppose you want to make your daughter guess an animal that you have in your mind. Okay.
Mhm.
So you will say, let's say, suppose you have a elephant in your mind and you want to describe it. You want her to see it. You are playing a game, so you want to describe it with mm, a description, word, audio description. Okay. How will you say? You will say, okay, there is a big animal with large footsteps and it makes noise when the animal walks. So now automatically there are many large animals, dinosaurs,
Yeah, there is an
hippopotamus,
explanation kind of thing.
explanation,
So
right,
your
right. So
explanation
better
kind
you
of,
explain, the
yeah.
better the inference, correct? Inference, she will be drawing inference from it.
Oh, okay, okay, okay. The
Okay.
getting the real picture of that statistic.
Why it happened, what is happening, that is inference. So
Mm.
if you don't describe well, will you be able to infer well? No, right? If you give wrong
Okay, okay,
description, and so that's the idea between descriptive and inferential statistics. Okay.
okay.
And part of description is to be able to plot the graph, and that's why we did the descriptive statistics here. And then once we go into matplotlib, you will see it actually implemented, the descriptions. Okay. Then your inference, we won't do much of the inference here, but when it comes to machine learning, we will draw into some error calculation, some bit of a practical thinking when it comes to. Of course, we won't go to hypothesis testing and all, but we won't test it, but you'll see the hypothesis and we will check the numbers automatically system gives, because this is not like data science, right? We are not doing any health statistics where we frame the hypothesis, then you check. We don't do that. Automatically, the algorithm is doing it, but you will see where the algorithms are using these hypotheses and estimations getting done. So we'll get that picture. And while Vikas was also asking me where is this material for some advanced statistics, so Vikas, the best material for advanced statistics is go to datatab.net. I was trying to figure out every way, but I think these people have the best because
Okay,
the
sir. I,
video tutorials are there.
okay, okay.
Have you seen that datatab.net? You visited anytime?
Uh, sir, actually, you showed that on in one of the classes, I guess,
Yeah, yeah, yeah.
by
So,
discussing the types of data.
right. This is, I think it must be here. Ah. So almost beyond what we will cover is here. I mean, this is for scientific. This is for real scientists. Okay. So you want man Whitney, you test, simply explain. Okay. You go and put, you have text, everything is explained. But I mean, this is endless. This is. Okay.
Yeah.
Nobody should go into a mindset where they say, I will read all these tests. Okay. Probably we'll be doing 60% of it. Only
Mm.
this advanced stuff we won't be doing, like this
Okay.
survival analysis, because this is more into your medical, medical
Mm.
stuff
Domain
and
specific.
domain specific. Yeah, that's the word, right? So this is time series analysis purely when you go into data science.
Yeah.
Okay, and so these are all you already know. I guess you already studied this,
Mm.
and this we will eventually do when we do linear regression. You will get the time series analysis aspect. What the
Okay.
analysis of variance, as you start doing analysis of variance from ANOVA, what is analysis variance? You go keep looking, then one factor, two factor, one factor with repeated, two factor. What is the difference? You'll understand eventually. Oh, then you'll understand the importance of that difference. So same
Mm.
way, I would urge our Manjunath also to start gathering this, you know, different kinds of see levels of measurement. Start from beginning. This is always there. Statistics playbooks, download free. Some playbooks are load some example. Yeah. And what is this? First step with yeah. So introduction to statistics, descriptive and inferential statistics. See, you see this picture where I got it from? You see this?
Yeah, right. So,
In fact, this is a piece of trivia that I'm telling you. I first got this picture from internet. Okay.
mm,
Then in the internet's pictures metadata, I found data tab because I used to find regularly three or four pictures with this color, and I felt
mm,
it's very nicely done. So because of the metadata of that picture, I found out that there is something called data tab. Then I met them, I contacted the CEO, and we got in a discussion about statistics, and it was fun. It was really fun. And I said, hey, I want to represent you guys in India.
mm.
And literally, you won't believe there are at least around 25 to 30 people regularly, every day they buy license of data tab.
Okay.
Okay,
Yeah.
so scientists are buying licenses. So it's a very good. The people why they buy because of this extra, you know, a very dynamic tutorial it is. Nobody has done it so easy, so that you can just check. See, you can really read. I mean, this also begs that statistics needs cannot be taught like this. Not cannot be taught like this. It requires. So that's the reason I said let me show data tab itself for you guys so that that will become your uh, benchmark material. Okay. Now, descriptive versus inferential. Quickly, let's scan through this. Descriptive statistics concerned with describing the target population. Manjunath, read. Read this. Descriptive and inferential. This will finally nail the coffin for us. Concerned with describing that population. Is there, Manjunath?
Yeah, I'm there. I'm
You read. You only read.
we
Descriptive.
are
Read
concerned
this.
with describing the target population. So we are targeting some population or to describe what.
No, we are not targeting some population to describe. We are describing the population. Concerned
Oh,
with describing the target population. There is a target population. Means what?
so
Some
we are
population.
deciding the target population.
No. No. See, the client says, I want to study the mating habits of rabbits.
Okay.
Now, that target population is what? Rabbits, no?
Yes.
We are trying to describe the mean value, how the mean value changes
Okay.
in every generation. Hundreds of questions we'll start asking and we'll describing it. Okay.
Okay.
Once a description has happened, see inferential statistics. On the basis of the description, you will make inferences from the samples and generalize them to population. What am I saying? Inferences from the sample and generalize them to population. What it means is like I told you, no, what if, whether it will, what is the guarantee? That is generalizing them to the population. Whatever sample you took, whatever stats you calculated, that was on the sample. Whatever generalization you did was on the population. Okay. Now, descriptive, read this.
Organize, analyze, and present the data in a meaningful manner. Yes, that is descriptive. So the sample data is into a meaningful manner.
Hmm. This one.
Compares, test, predict future outcomes. So with the larger population, we are going to compare the sample data and we are testing that and the future. That means we are giving the output wave for a larger populations. Final results on from the charts, table and graphs. Yeah. We are showing in the charts and graphs tables.
Hmm.
So final result is probability scores. So here numbers will become in the inferential statistics.
Correct.
So we can plot graphs also here, I think. So that is functionality will be there. So the numbers can be shown in the graphs also. Correct, sir?
Correct, correct, correct. Absolutely.
Okay. Describes the data which is already known. So the ti- so it already known ಅಂತಂದ್ರೆ in the sense the output of the descriptive statistics.
Whatever sample data you collected, that is the known data. So
Known
under
data. Okay.
descriptive statistics, you describe that data which you have collected.
Okay. Tries to make a conclusion
Con-
about the population that is behind the data available. So we are concluding the data in inferential statistics. So means that
no,
is the end result.
yeah. So tries to make conclusions about the population that is beyond the data. Means what?
Yeah. Yeah. Based on the data available, so whatever the data we have in front of us, so based on that we are deciding about the larger populations, what they
Correct.
think.
Absolutely. Absolutely. Out of 150 crore people, you can maximum collect 1 crore data points. Right. On 1 crore data point, you do all the statistics drama. But finally, whatever you find here, oh, you say, oh, 1 crore means whole of Indians are now not liking Maldives and they want to go to Lakshadweep. Out of 1 crore
Yes.
survey points, if you say that, are all the rest of the 149 crore people also same, doing the same? This conclusion
Mhm.
has to be done in inferential statistics. Now, the final one,
Yeah. Yeah.
tools,
Tools.
methods, and
Measure- Yeah. Measuring central trend and tendency, mean,
hmm,
median, mode, spread data, yeah, range, standard deviation, etc. So what
hmm,
are the tools we are used
hmm,
to measure the sample data
hmm,
and to know the exact what the people thinks?
hmm, 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 right.
Yeah, here tools we are using hypothesis tests, analysis of variance. Yeah. So ಇದನ್ನ ಮಾಡಿಲ್ಲ ಅಲ್ಲ ಸರ್ ಈ ಹೈಪೋಥಸಿಸ್ ಟೆಸ್ಟ್ ಅನಾಲಿಸಿಸ್ ಮಾಡಿಲ್ಲ ನಾವು. So
Madila,
ಇದಾದ್ರೆ
Madila,
clear.
no, no, no. This hypothesis and analysis of variance, this we will not cover as a theoretical subject here. Okay. This, of course, this is not a part of your ML engineering. Okay. This is part of statistical science.
Okay.
We'll do it in, suppose, time series analysis. We'll brush upon it. It's not a big deal. I'll explain the whole four sectors of analysis of variance. You'll get the idea of what is happening. But
Yeah.
everything today is quickly done, right? Hypothesis test, you'll understand how to. We won't go into the hypothesis test like a data scientist would do for a medical problem. We will understand
Yeah.
what a hypothesis is when we learn about when we come into linear regression and polynomial regression. We will see what the hypothesis is and what those p values are, and we are going to you know get that foundation so that next time you want to go deeper, you will have that foundation for you.
Okay.
Otherwise, we can, even if you go into deeper and deeper and deeper into statistics, you can spend 3 months just trying to do this. But
Okay.
while I'll give you the practical insights of it, I'll make sure
Okay.
that you understand this p value.
Yeah.
Okay, then there's a different value. You will get there. Don't worry about it.
Yeah.
But
Okay. So,
I have
so
already,
just
huh?
yeah, yeah, it's good.
Vikas, you're saying something?
No, no, no.
No,
My,
sir, I was
Vikas, tell.
no, sir, I was not saying anything.
Okay,
Manju was saying something.
okay.
yeah,
So
that's what I'm just mapping the PDF to descriptive statistics. So that is another thing what I'm not able to see in this particular comparison. So the PDF things can we put it into the descriptive statistics? Correct, sir? My understanding.
yeah, the probability density function, no?
Yes,
This graph, PDF.
is my PDF. Third point.
This,
Yes.
if
Now
you
I
are
connected.
if you are
Now I connect.
looking at it, If you're looking and visualizing it, it is describing the stats. But finally, you're saying you're somewhere enjoying your holiday in Lakshadweep, and even my examples are Lakshadweep now. Crazy.
Even enjoying holiday in Basham Circle is also okay.
Okay, okay, right, sir, right. If you're enjoying holiday somewhere else and your client, your subordinate junior calls you and and says, "Sir, we have found the PDF," and then you will not ask him to send a picture of the PDF on WhatsApp. You'll say, "Okay, between one sigma, between first sigma, how many percent? How much score? What's the probability scores?" Right? That's what you will
Okay,
ask. They'll say, okay, first sigma to minus one sigma, I'm finding only 18% of the data. Rest are all flat. Acha, what's the skew? We'll ask. Right? You
yeah.
can ask all these numbers. Everything is eventually a number only. But
Okay, sir.
to infer something, you need to visualize it. Okay?
ಅರ್ಥ ಆಯ್ತು ಸರ್ ನನಗೆ. So I am
ಅರ್ಥ
clear about
ಆಯ್ತಲ್ಲ?
this inferential statistics and descriptive statistics. I will put a note after watching your video. I will put it in my way. So what I understood. Not maybe the exact sentence I can do it, but I will put it in my simple way. So how
Right.
I understood.
Right, right.
ನನಗೆ ಅರ್ಥ ಆಗದೆ ಇರೋದು ಯಾವ್ದು ಗೊತ್ತಾ ಸರ್? ಮೇಲ್ಗಡೆ ಬನ್ನಿ ಹೇಳ್ತೀನಿ. ನೀವು ಹೇಳಿದ್ರಲ್ಲ ಕನ್ನಡದಲ್ಲಿ ಒಂದ್ಸಲ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಬಿಡಿ ಅಂತ, ಅದೊಂದು ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಷ್ಟೇ.
Percentile, is it?
ಅದಲ್ಲ ನೆಕ್ಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ರಿ. ಹಾ
Rank.
ಇದು ಹಾ ಇದು
ಮಾಡ್ತೀನಿ ನಾನು ಕನ್ನಡದ ಸ್ಮಾಲ್ ಡಿಸ್ಕ್ರಿಪ್ಟಿವ್ ಮಾಡಿ ಕಳಿಸ್ತೀನಿ. ಓಕೆ. Now let me end the today's in 10 minutes. I will end it. So now comes the final part, central limit theorem. So Vikash, would you like to explain central limit theorem?
Yes, sir. So, as the number of sample size, so we discussed about the sample size some time back. So, as we increase the number of samples, we see that so there is a threshold which we have, like say 30 as the sample size. So, as we increase the number of samples beyond 30, we'll see that the distribution will follow a normal curve. So it will be like a smooth normal curve which comes out. So that is what the central limit theorem tells us. So even in this diagram, we can see that uh, the first scenario where the sample size is probably less, that is just one sample is what we are considering. At that time, the distribution s- uh, is zigzag. However, as we increase the number of sample size, it will follow a smooth normal curve.
Let's see. As we increase this sample size, okay, fine. Let me explain. The significance of this is also important. So let me explain it properly. Huh? Okay, both of you now see. Again, from the beginning, there is an event. Suppose in this event you collected 1 crore data points. Big, large experiment, 1 crore data point was collected. So that 1 crore data points PDF is looking like this. Mu is here between first sigma and minus sigma like this. I told you, no, like 18% and all that. Then above that, maybe there is a lot of, then below a certain minus 2 sigma, there is again total. This is what? The total space is 100%. Agree with me? This is a probability space. This is the real event. Whatever event it is, doesn't matter now. This is its distribution. What? Probability density function. This is how the data points are distributed for that event. Now I'm going to do something. I'm going to do an experiment. I'm going to take randomly 1 lakh data points. What randomly, yeah?
Yeah.
Randomly I'll take 1 lakh data points and I will do the same. I will take that 1 lakh data point and just for the sake of it, I'm building, instead of building a PDF for 1 crore data points, whatever randomly I've taken, no, let's see how the PDF is for it. I plotted this and I also got the mean value. X1 bar here means mean value, your mu1. Okay, this is your mu2, this is your mu3, and your mu n. Hmm? I noted the mu1, so I said sampling. This is random sample one. Okay, and what I'm doing here, I'm sampling. So I make a note here, sampling attempt 1, I got a certain mu value, mu1. Sampling attempt 2, while doing the 2, I am not going to do the second random on the remaining 99 lakhs. No, I will put this 1 lakh back. Means whatever random was selected out of 1 lakh, it still is 100 here. From again the 1 crore data point, again one more random 1 lakh I'll take. You're following?
Yes, sir, yes,
One
sir,
more
yes, sir.
run. So do you think these 1 lakh people, 1 lakh data points and these 1 lakh data points will be same? No, right? Because
No, no, no.
randomly
It
it
can't be
won't be.
same.
Second sampling attempt I will take mu 2. Third sampling attempt I will take mu 3. Fourth sampling attempt I will take mu 4. Like this, I can do as many number of times as I want, correct?
You make cutting into the piece. Everything
Yeah,
is.
yeah. So I can do 2 crore times, correct?
Yes, you can do that. Yes,
Again and again, again and again, again. I can keep doing it, no?
yes, yes,
Now,
yes,
don't you
yes,
think I have 2 crore mean values now?
yes.
I first had 1 crore event, 1 crore event per data, but now I have, because of the sampling, I have 2 crore data points which has come out of this random 1 lakh sampling.
Yes.
What if I plot this? What is the PDF of this? These mean values itself. That PDF will always be a normal distribution.
Okay. So end point is normal distribution.
I'm not
End
saying that.
destiny.
I'm
End
not.
destiny.
It's not like end destiny. No, it's not like. This is a finding. Okay. Suppose you start with this.
Yes.
Suppose it was a income inequality distribution that you have. If you
Okay.
do the same thing, no, mean value, mu, you will again get normal distribution.
ಅದೇ ಸರ್ ಈಗ ಕೊನೆಗೆ ಅಲ್ಲಿಗೆ ಬಂದ್ರಲ್ಲ.
ಕೊನೆಗೆ ಅಲ್ಲಿಗೆ ಬಂದಿದ್ದು not because the event will become this. It is because we are doing this. We are
Okay,
taking
okay. The
random samples. That's
actual one is
actual.
reality was
Yeah, reality
reality
is
is the
this
reality.
only. Reality is
Yeah,
the
reality is
reality.
that is a
Yeah. But if you keep doing the random one,
okay,
see,
okay, okay,
distribution of the sample mean
okay,
is always a normal distribution. This is a
okay,
mathematically proven concept. You don't have to
okay,
prove it
okay.
mathematically. You have to think why. So that is what your assignment today is. Think why it is like that. Huh, Vikas? Don't, it's not, it's more like have some perspective on why it is like that. Why should it
Yeah.
be like this? Because if it is a theorem, you should have some intuition about it, no? So you take that as, because for you that is the assignment, and for this one, our Manjunath, the assignment is to re-watch this, spend some more time,
Yes,
and tomorrow let's have a small test on
okay.
stats in the morning. Okay? Okay?
Yes, yes.
Chalo, I'll close the session and I'll put it on recording now. Hmm? I'll put it on the this one. Right. Bye bye. Hmm? Sure.
Yeah, thank you. Thank you.
Thank you, sir.
Thank you.
Bye.